they want us to graph this quadratic equation. Remember, quadratic equations are always going to be parabolas when you graph them. So the easiest way to graph this equation, which is in standard form, is to find the vertex first, which is going to be negative b over 2a. That's going to be your x-coordinate of your vertex. And then we'll find the y-coordinate when we're done with that. So let's do that. Negative b would be 8, because b is negative 8, and a is negative 1, so 2a is negative 2, which means my x-coordinate of my vertex is negative 4. So now I'm going to find my y-coordinate, and by the way, that also tells me what the vertical asymptote is going to be, or I'm sorry, not vertical asymptote, sorry about that, what the axis of symmetry is going to be right there. X equals negative 4 is the axis of symmetry. Now let's find the y-coordinate of our vertex. Let's plug in negative 4 in for x into our original equation to find out what the the y-coordinate of our vertex is. So we have to be very careful with this negative sign. This is the thing most people do wrong. I'll do it down here. Y equals negative 4 squared. Notice that the negative is not being squared, just the 4. Minus 8 times negative 4 minus 13. Now let's simplify this with order of operations. So this is negative 16 plus 32 minus 13. Negative 16 and negative 13, well, I'll just do it like this. This is 16 minus 13, which equals 3. So my y-coordinate is 3. So here it is right here, negative 4 comma positive 3 is over here. That's my vertex. And notice that it was a negative a, which means it opens down. I'm going to show you a trick. You could either do your x and y. Well, first let's just find the t-chart. So if I plug in negative 3 for x, and I plug it in over here, let me do it in a different color, do it in orange. If I plug in negative 3 for x into here and here, I'll get the value for y that is associated with negative 3, but I know it's going to be positive 2. And let me tell you why I know that. Every time you have a quadratic equation, this number right here in front of the x squared is kind of like your slope. It's not really the slope, but it's like your slope. And so what that tells you is, if it's positive 1, that tells you that when you go over 1, you're going to go down 1 squared. So if I go over 2, I'm going to go down 2 squared, which would be 4. But that number in front, then you're going to have to double, whatever that number is, you're going to also have to multiply it by that. So let me give you an example first before we go on. Let's think of y equals x squared, just your normal graph. 0, 0 is going to be your vertex. If I go over 1, I'm going to be at positive 1, but I'll also square that, so I'll be at positive 1. So 1 comma 1 is a point, and also negative 1 comma 1 is a point because of symmetry. If I go over 2, what am I doing? To 2, when I plug it in for x, I'm squaring it. So I'm going over 2, I'm going to go up 4. 1, 2, 3, 4. So that's my point, and similarly, symmetrically, if I go negative 2, I'm going to go up 4. If I go over 3, I'm going to go up, instead of 3, I'm going to go up 3 times 3. I'm going to go up 9. So I'm going to be up here somewhere. So your quadratic equation is going to be up there, even higher up there. But your quadratic equation, what it's doing is, it's instead of going a constant rate of change, like a line is with slope, you're going up, you're squaring. Your x is, whatever you plug in for x, you're squaring that, and you're going up that much for y. So what if I had a number in front of that? I'll use green. What if I had 3x squared? What would 3x squared be? Well, every time you plug in 1, you're going to go up 1 times 3. If you plug in 2, you're going to go up double, or you're going to square that, but then you're going to go up times 3. You're going to increase by a factor of 3 the distance that you're going up. So my graph for the green graph, y equals 3x squared, for instance, I'm going to go over 1, still starting at 0, 0, I'm going to go over 1, but instead of up 1, I'm going to multiply that by 3 now, so I'm going to be up here at 3. And when I go over 2, instead of going up just 4, I'm going to go up 4 times 3, so 3 times as much as I normally would go up. I'm going to go all the way up there, and what happens is your graph is what we call stretched. You're stretching your graph inside there, because that 3 right there is kind of like the slope. It tells you what factor you need to multiply it when you square those numbers. Alright, back to our problem. So for this problem right here, I know, let's see if you understand what I'm saying. I know that when I start here at the vertex, because that was a -1, that means it's upside down, but I'm not multiplying it by another factor. I'm just squaring every x value. So if I go over 1, I'm going to go down 1. If I go over 2, I'm going to go down 2 squared, which is 4. So that point should be -2 comma -1. And if I check that, let's plug in -2. So I'm going to plug it in right here. -2 squared is +4, but there's a negative in front of it, so that's -4. This is +16, and this is -13. When I add these together, I get -1. So -2, -1 is the point on my graph. And the easy way to do that, again, at least for me it's easy, because I understand how quadratics work, and that's what I'm trying to encourage you to do as well. If you're going over 1, you go down 1 squared, which is 1. If you're going over 2, you're going down 2 squared, which is 2, because your number in front of the x squared, or the a as we call it sometimes, is -1. And then you also have symmetry here. So if I go over 1 in the left direction, I'll go down 1. Over 2 in the left direction, I'll go down 4. And that's why your graph looks something like that. So that's not just how to graph it, but how to understand it. So it's really more than just doing the problem. It's doing it and understanding the easiest way to do it. Good luck.